Hello viewers, this is Teacher Nixon as usual. Today I want us to cover something on polygons. Kindly remember to subscribe and to share. Let's first of all start by knowing what is a polygon. We define a polygon just as any three or more sided figure. For example, a triangle is a polygon. A rectangle is a polygon because it has four sides. We refer to it as a quadrilateral. Quad means four. We also have a five-sided figure. We refer to it as pentagon. So any given figure which has either three sides or more, we refer to it as a polygon. And I want to mention various types of polygons that we have. I will start with the first one, that is triangle. And we have said triangle has three sides. That is common to all. I want to believe everyone knows that a triangle has three sides. Then we have a quadrilateral. A quadrilateral has four sides. It has four sides, and that way we refer to it as a quad. Then we have a five-sided figure. Five-sided figure or a five-sided polygon, we refer to it as a pentagon. Penta means five. Pentagon. So a five-sided polygon, we refer to it as a pentagon. Then we have a six-sided figure. Six-sided polygon, we refer to it as a hexagon. Then we have a seven-sided polygon, we refer to it as a heptagon, like this, heptagon. This one is seven. We have said we have hexagon. This is six-sided figure. Then we have pentagon. This one is a five. We have octagon. This one is an eight-sided figure. We also have nonagon. This one is a nine-sided figure. We have decagon. This one is a 10-sided figure. We also have maybe like 12-sided figure. Refer to it as the decagon. Yeah, this one is 12. We also have 15. Yeah, we have 15. We refer to it as a decagon. This one is a 15-sided figure. We also have a 16-sided figure. We refer to it as hexadecagon. Then 17 heptadecagon, 18 octadecagon, 19 nanodecagon. So those are various types of polygons. Let's start with the first concept, how we can get the sum of interior angles of a polygon. Sum of interior angles of a polygon. Sum of interior angles of a polygon. So sum of interior angles of a polygon is given by this given formula. Sum of interior angles is given by 180 to bracket n minus 2. This one can also be written as 90 into bracket 2n minus 4. Let me briefly elaborate on this given formula. A triangle has three interior angles, and if you add or if you take the sum of interior angles of a triangle, you will get it as 180. So we use that given concept to calculate the number or the sum of interior angles of any given polygon. How do we use that? For example, if I have a five-sided figure, for instance, a five-sided figure, let's take maybe a pentagon. I'm going to sketch it here. A pentagon. Pentagon. So a pentagon, we have 1, 2, 3, 4. Yeah, 4, 5. Let's see how many 1, 2, 3, 4, 5. How many number of triangles can be found in this given figure? So we have 1, we have 2. So we have 1, 2, 3. So these are number of triangles. So if I want to get the sum of interior angles of a pentagon, I will multiply 180 by times what? The number of triangles, because we know that sum of interior angles of a triangle add up to 180. So I take 180 times the number of triangles. So in this given formula here, n minus 2 represent number of triangles. Number of triangles. N minus 2 represent number of triangles. Take for example a figure like hexagon. We know, or I have said that hexagon is a six-sided figure. So I have one side 1, 2, 3, 4, 5, 6. Upper n equals to 6. Let's see how many number of triangles can be obtained from this. You'll have 1, you'll have 2, then I will have this. So you have 1, 2, 3, then 4. So number of triangles here are 4. Number of triangles. So if the number of sides are 6, the number of triangles are what? Are 4. If you take for example 7, and you divide or you find the number of triangles inside a heptagon, you will realize that the number of triangles inside heptagon will be 5. So anytime you take the number of sides, then you subtract 2, you will obtain the number of triangles inside that given polygon. For example, if you take a decagon is a 10-sided polygon, and you want to know the number of triangles that are in a decagon, you'll just need to take the number of sides, that is 10, you subtract 2. So 10 minus 2, you get 8. So a decagon has 8 number of what? Triangles. So to get the sum of interior angles of a decagon, you need to multiply 180 times the number of triangles, that is 8. Then you get your answer. So that is where we obtain this given formula from 180 sum of interior angles of a triangle, then n minus 2 gives us the number of triangles. For example, if you take a triangle, that means n equals what? To 3, and you substitute it back here. You will say now n minus 2. So this one will be 3 minus 2. So 3 minus 2 is 1. If you say 1 times 180, then you get 180. So that formula holds. Let's have maybe some few examples. If you are told to find sum of interior angles of an anagon. So we just need to know that an anagon is a 9-sided polygon. So in our case, in our solution, we'll have now n being equals to 9, and then we apply our formula, sum of interior angles will now be equals to 180. Then number of sides, that is 9. Now minus 2. This gives us 180. Into 9 minus that one is 7. So times 7. If you multiply this, 7 times 2 you get 2. Then 7 times 8 you get what? 62. Is that 62 or 63? 56. Yeah, 56. So 6. Then 7 times 1 plus 5. That is 12 what? 60. Is that right? Something like that. That's what we need to do. We just need to multiply. You can also use this instead of using that formula. You can also decide to use this 19 to brackets 2n minus 4 Then you just need to substitute. So in our case we have n being equals to 9. So you just need to substitute. So sum will be 90 into bracket. We'll have now 2 times 9, which gives us 18. Then we subtract 4. So this one will be the same as 90 into bracket. So we have 18 minus 4 gives us what? 16. So this one is 18 minus 4, and you get your answer as 90. times what? 16. So if you multiply that, you will get your answer. That's how we can get the sum of interior angles of any given polygon. I want us to learn another concept still on polygons. That is the sum of exterior angles. Sum of exterior angles of a polygon. Sum of exterior angles. Sum of exterior angles. Sum of exterior angles. Sum of exterior angles. So sum of exterior angles is given by what? Let me just draw any polygon here. For example, 5, pentagon. A pentagon. So I have 1, 2, 3, and before, then I have 5. So let me extrapolate this line. So I have that exterior angle. Then I have this exterior angle, then I have this exterior angle, then I have this exterior angle, then I have this exterior angle. So you can label this maybe as point A, we have point B, we have point C, we have point D, then we have point D, A, B, C, D, E, like that. So let's say maybe this angle here, this exterior angle is A, then the other angle is let's say this one B, then we have C, we have angle D, then we have angle E. So sum of exterior angles, So what you should know is that if you take the sum of exterior angles, that is A plus B plus C plus D plus E, it's supposed to give you 360. So A plus B plus C plus D plus E is supposed to give you what? 360 degrees. 360 degrees. I don't want just to prove this, but it's simple. You know, this interior angle and exterior angle add up to 180. They add up to 180. So you can be able to find the interior angle here. And when you find the interior angle, if this one is regular, if it is regular, you can be able to get this angle and it will be common to all. So if for example you get this one as let's say 60 degrees, this one will be 60, this one will be 60, this one will be 60, this one will be 60. And now the exterior angle, if you subtract there, if you subtract the interior 180 minus the interior angle, you will be able to get the exterior angle. So anytime you add, it doesn't matter the polygon or the number of sides of a given polygon. The sum of exterior angles of any polygon will always add up to 360 degrees. 360 degrees. So sum of exterior angles will now be equals to 360 degrees. I don't want to go to the proving bit. So those two concepts that we have learned, how do they help us to solve various questions on polygons? This is a very common question that always, of course, comes with 3 marks in section A. So I want us to apply the concept learned, that is the sum of interior angles of a given polygon is given by 180 to bracket n minus 2 or 90 to bracket 2n minus 4, and the sum of exterior angles adding to 360 irrespective of the number of sides. I want us to use those two concepts. I summarize them in 5 points that are going to help you solve any question on polygons. I'm going to start with the first key points. Number 1, what you need to know to solve any question on polygon. You need to know how to find the sum of interior angles. Sum of interior angles. And we have said this one is gotten by 90 into bracket 2n minus 4. Or it can also be gotten by 180 to bracket n minus 2. We have said n minus 2 represent the number of triangles inside a given polygon. Concept number 2, you need to remember that sum of exterior angles of a polygon equals to 360, or add up to 360 degrees. Add, let's say add up to 360 degrees. Add up to 360 degrees. That is point number 2. Point number 3. Point number 3. If you know the size of exterior angle, you can be able to know the number of sides a given polygon has. If you have been given an exterior angle, you can be able to know the number of sides a given polygon has, and hence the name of the polygon. So how do we do that? So to know the number of sides, you need to take 360. Why 360? Because you know exterior angles of any given polygon add up to 360. We divide by exterior angle. Divided by one of the exterior angle. That is how we get the number of sides. Concept number 4, or point number 4 that you need to know for you to solve any question on polygons is how to get the exterior angle. If you know the number of sides. So exterior angle can now be obtained by taking 360 degrees divided by what? Number of sides. Number of sides. Then the last concept that you need to know, that is number 5. That the sum of exterior angle, the sum of interior angle will always add up to 180 degrees. So if you say interior angle, I'm saying that the fifth concept, or the fifth point that you need to know, is that sum of interior angle plus exterior angle will always give you 180 degrees. And for you to apply this, it's always good to just make a sketch of any given polygon. So you can take one as the exterior angle, then the other one as interior angle. So if you take exterior angle plus interior angle, it will give you 180 degrees. I can assure you, with these 5 points, you can be able to solve any question on polygons. So let's do some few examples. So we have these 2 examples that I want us to have as part of the example 1. So the first question is asking us to name a regular polygon with an interior angle of 60 degrees. To name a regular polygon with an interior angle of 60 degrees. Now, from the concept that we have learned, for us to solve this question, or for us to know what type or the name of this given polygon, we need to remember point number 5. That is, if you take the sum of interior angle and exterior angle, you're supposed to get 180. Now here we have been given an interior angle. So is it possible to get the exterior angle? And if you get the exterior angle, you have already learned another concept, that to get the number of sides, then you need to divide 360 by the exterior angle. So those are the 2 concepts, or the 2 key points that we use. Number 1, we need to know that interior angle plus exterior angle equals 180. Number 2, we need to know that 360 divided by exterior angle gives us the number of sides. So let's do that. So I have now 60 degrees plus, let's say the exterior angle is represented by E, then it's supposed to give us 180 degrees. Then E, exterior angle, will now be equals to what? 180 minus 60. This gives us 120 degrees. Now, to know the number of sides, we have said it is 360 divided by the exterior angle. And now this one will be 360 you divide by 120. And how many sides do you get? This one is 3. So this one tells you this one is what? A triangle, because the number of sides are what? 3. So name a regular polygon with interior angle of 60 degrees. That interior angle, that polygon will be a triangle. That's how we solve that question. Let's look at the other question. Find the number of sides of a regular polygon with an exterior angle of 36 degrees. So we use this given concept. That is, number of sides n can be given by 360 divided by the exterior angle. We have already been given the exterior angle as 36, so this one will be 360 divided by 36. We cancel, we get this one as 10, so the number of sides there is 10. So the name of the polygon here will be what? Decagon. Let's also have another example. We have this given example 2 here, which tells us that the size of interior angles of a regular polygon is 5 times that of exterior angle. Find the number of sides of the polygon. The size of interior angle, supposed to be size of interior angle of a regular polygon is 5 times that of exterior angle. Find the number of sides of the polygon. Find the number of sides of the polygon. How do we solve such a question? We are still going to apply the 5 key points that we have learned, but first we need to let something here be. So let's say, let exterior angle be, say, x degrees. So interior angle is 5 times the exterior angle. So therefore, interior angle will now be equals to 5x degrees. But we know something, that if you add exterior angle and interior angle, you are supposed to get 180 degrees. So we can say, but x degrees plus 5x degrees is supposed to be 180 degrees. So you can be able to get the value of x. So 6x degrees equals to 180 degrees, and x degrees now will be equals to 180 divided by 6. That gives you 30 degrees. Now x, we had said it is what? Exterior angle. So that means our exterior angle is 30 degrees. So now to get the number of sides, how do we do this? We just say what? Number of sides is given by 360 degrees, because the sum of exterior angles add up to 360. Then we divide by the exterior angle, one of the exterior angle, if the polygon is regular. So we now have 360. We divide by the exterior angle, which is what? 30. So 0 by that we get 12. So this one is a 12-sided figure, which we refer to as dodecagon. I want to believe we have been able to learn one or two things that are going to solve you any question involving polygons. Stay tuned. Kindly remember to subscribe and to share. Goodbye for now.